Okay, so now we're going to go ahead and start looking at the rules of a sinus rhythm. So this should be a review from class, but we're going to go through this and I'm going to give you quick reviews on here. So essentially, if I start out and I gave you a QRS, if you remember that's the first thing that we're going to measure, if I give you QRS that looked like that, would that be a wide or a narrow QRS? Well, most people are going to say that's a narrow QRS. If I gave you one that looked like this, well, that's a pretty wide QRS. So then if I go to one that's over here, kind of like that, that's kind of in the middle. So what you're going to find is we have to come up with a very specific guideline. Now this doesn't mean that somebody's going to die if that doesn't fall in the narrow category, but a normal QRS for our purposes here is actually going to be narrow. So for our rules here, I'm going to start out with our sinus rules. First one I look for is the QRS, just because the QRS tends to show up a lot easier. So the QRS should be narrow. Well, a narrow QRS is defined as one that's less than or equal to 0.12 seconds. And doing a little bit of conversion here, it's the same thing as saying less than or equal to 120 milliseconds. Now, 120 milliseconds is the same thing as 0.12 seconds. This doesn't mean that somebody that has 121 millisecond QRS, their heart's in really serious danger. It's really probably not in any danger at all, and arguably the difference between 119 and 121 milliseconds is extremely negligible. There's nothing, it's barely worth mentioning. However, we have to draw a line in the sand somewhere. So essentially the guidelines are that if the QRS is greater than 120 milliseconds, it's considered to be a wide QRS. If it's equal to or less than 120 milliseconds, it's considered to be a narrow QRS. Now, once we have that, the next thing that you tend to try and look for is a P wave. So if I'm looking for a P wave on here, let me go ahead and I've got a red arrow here. I have a P wave right there, have another one right there, have another one right there, and another one right there. So, and that continues on. I've got a little rounded P wave, a little hump that shows up there. So the rule for P waves is that they are typically going to be round, upright, and symmetric. So with my P waves, if I drew a P wave, it looked like this. It's a little soppy, but you get the idea. So is that round? Well, sure, it's round. Now it doesn't have to be a full circle, it's a half circle here, but it's just the rounded part there. So that's round. It's not pointy, it's round. Is it upright? Well, from the baseline, it's pointed upwards, pointed toward the top of the screen. So yes, that's upright. Is it symmetric? Yeah, essentially it goes up and down with a very similar shape. Now if I draw another one over here, and I make it look like this, is that round? Well, no, that's not really round. Is it upright though? Yes, it's pointing up. And is it symmetric? Yeah, it goes up and down the same way, so it looks nice and symmetric. If I drew one that looks like this, is that one round? Well, no, it's got kind of a point to it. Is it upright? Yes. Is it symmetric? No, it's kind of going up at a slow slope on there, and then it drops down very, very quickly. So it's not really symmetric on there. And then let me draw one more finally here. If I do this, is that one round? Well, sure, that looks round. Is it upright? No, it's not upright. And is it symmetric? Yes. So 2 out of 3. So 2 out of 3 ain't bad, is it? The problem here is that there's one critical rule. the one thing that you have to qualify as a normal P wave here is that it must be upright. That is non-negotiable. So you must have an upright P wave. So of these, this one would be fine. It fits all three categories. This one, even though it's pointy, still fits. This one is okay, even though it's strange. It's like, well, it's not round and it's not symmetric, but it is upright, so it hits the one and only critical criteria. Then this one over here, though, that doesn't qualify as a normal P wave in this case, and the reason is that it's not upright. Well, what does that mean? You're going to have to come back in a few weeks and we're going to go through what these different abnormalities are. Like I said, I'm giving you guidelines on what is a normal rhythm here in this case. So when anything deviates from normal, we just have to come up with a slightly different variation on the name for it. So let me clear away some of the clutter here. However, what I will do is let's get this upright circled again, because I want that to be key. So that upright part, very, very important. So I have to have an upright P wave. Now the next one that I want to do is I want to check what's called the P to R ratio. Now what do I mean by P to R ratio? A P to R ratio, sorry, I dropped my screen there. What I mean by P to R ratio is a comparison of when I have P waves, do I have QRSs with them? Well, you can see on this one, I'm kind of sticking with the same color here. I have a P wave and I have a QRS with it. I have a P wave there and I have a QRS with it. Have a P wave and I have a QRS. P wave, QRS, and that continues all the way throughout. We're going to talk about this a little bit more in class. I'll kind of walk through it and I'll show you some variations on it. But essentially, what we need to see is this needs to be a 1-to-1 ratio, which means that every time you see a P wave, you'll see a QRS. Every time you see a QRS, you'll see a P wave. They should be an equal match between the two of them. If it's something that's clipped off at the beginning, for example, over here, you've got a P wave and a QRS, so you can actually see that. And at the tail end here, you have a P wave and a QRS, so you can see that. If one of those was clipped off to where you just had a P wave dangling by itself and the QRS was clipped off, or if over on this side, the P wave, or on the left side here, your P wave, this piece over here, the P wave is clipped off and you just see the QRS, that doesn't blow our PR ratio. You have to go by what you can see. But essentially, if you have a 1-to-1 ratio, you shouldn't have any stray P waves in the middle or stray QRSs in the middle. I'm going to go ahead and get rid of a few. Whoops. Let me get that 1-to-1 ratio back here. I can leave the arrows up top. That won't hurt anything. But the PR ratio needs to be 1-to-1. So it's an equal match between the two of those. Now the next one that we're going to do, I'm going to jump over here and switch colors for. We're going to use the blue. So on this one, it's a PR interval. And while we've got the rhythm up top, I'm going to draw an example of that over here. So if I have a single heartbeat, we have several different components. You know what? Actually, I'm going to redo that. So we got a smaller P wave here. Nice big QRS. Almost starting to look kind of wide. But let's make this T wave a little bit more prominent. That's almost dangerous T wave, but anyway, that's for another day. But I have a P wave at the beginning, then I have the QRS, and then I have a T wave. Not my greatest effort, I admit, but it gives you the idea, and it allows us to measure what we're looking for here. So if I want to look, I want to try and determine where is the beginning of my P wave. So the beginning of my P wave, I'm going to go ahead and highlight that here in orange. It starts right there. That's the start of my P wave. And then I'm going to come over here in purple and I want to find when do the ventricles actually start to move. So if I come up here, right there is where my ventricles are starting to move. So I'm measuring from the beginning of the P wave to the beginning of the QRS. And that would be my PR interval. I'm going to show you how to do this in another video yet, but essentially my PR interval, I have a very set range that this needs to be. It should be between 0.12 to 0.20 seconds. And that translating again here is 120 to 200 milliseconds. So that's another important rule here. Last but not least, what I want to do is I want to look at my R to R interval. So my R to R interval and with this, I'm not looking at what the actual distance between the beats are. I don't care that much at this point. That'll help me determine my rate. It'll give me some other really good information about this. But for the moment, what I'm interested is the distance consistently the same. So the R to R interval, when I'm measuring this, and hopefully this green's going to show up on this rhythm. Not great, but you can kind of see what's happening. If you look at this gap here, you look at this range, I'll tell you what, let's do a really dark version of green here. Let me try this. See if this works a little better. That gives you the idea. Okay, it's almost black, but anyway. So this distance is between the beats. So I'm kind of measuring my the big, tall, up, down, spiky, pointy things here. And if you look as I measure this out, I'm finding that these are all about the same. Now, we're going to talk about graph paper shortly, but if you look as I do this, I could count that out, and it's pretty much the same distance every time. You got about the same number of blocks. I'm not worried about micromanaging this. Now, if you count and do the math on there, you look at those little teeny tiny blocks in there, these are about 16 small blocks apart, between 15 and 17, but right around the 16 mark per beat. So there's about 16 small blocks between each one of these. And it's consistent. If one of them is 17 and all the rest are 16, that's actually considered to just be regular. So irregular would be something where it's just not a really consistent thing. So for example, if I had a rhythm and I went that's a nice regular rhythm. It's consistent. Kind of fast for heartbeat, but you get the idea. If it was you can tell that would be an irregular rhythm. There's irregular pauses. The distance between each beat is not going to be the same. So the R to R rhythm here, one would pretty logically guess this should be regular. So if I have all 5 of these characteristics are met, the QRS is narrow, the P waves are upright, the PR ratio is 1 to 1, the PR interval is between 120 and 200 milliseconds, and the R to R interval is regular, then I've got all the characteristics and all the makings of a sinus rhythm. Next videos, we're going to talk about how do we use the blocks and how do we actually determine a heart rate based off of that. But that's a quick overview of how to determine your different types of rhythms.